Question 16. If using compressed air as a protective gas, where should the compressor intake be located? Answer. The compressor intake should be located in an unclassified location. Question 17. When does electrical power need to be automatically disconnected? Answer. Purge systems require internal power isolation on pressurization loss, except if power disconnection may lead to a more dangerous situation. Safety critical systems, for example emergency shutdown, public address, general alarm system, which should remain powered when pressurization is lost. Many users require automatic power disconnection in Zone 2 and Division 2 if they believe safety is improved. Local operator reaction to alarms signaling pressurization loss is likely to be delayed. Question 18. Can the continuous air flow system cool electronic equipment? Answer. The continuous flow purge system is designed to prevent explosions, not to cool equipment. There is no guarantee that purge system will decrease temperatures inside the enclosure. Question 19. What about heat dissipation? Answer. Internally generated heat can dissipate through the pressurized enclosure walls or through attached heat sinks, if your equipment does not achieve your desired T rating. Question 20. Air leaks the most common problem in pressurization systems? Answer. Purge and pressurization systems work if your inlet supply is more air than air lost through leaks. If your air supply is too low, the inert gas or air pressure inside your enclosure is too low to exclude hazardous gas or dust. The purge process cannot purge hazardous gas or dust from the enclosure. You cannot safely operate electrical equipment or motors. The purge unit stops you or the control system firing up anything electrical. We appreciate some readers may be frustrated. Your plant is down. It's possible your purge system is doing its job and preventing explosions. For all systems check, the inlet compressed air pressure should be between 60 to 115 psi, 4 to 8 bar. The compressed air inlet pipe should be at least 3 by 8 inches or 10 meters internal diameter to ensure sufficient flow. Minimize bends for a smooth airflow. No preventable air leaks from the enclosure or housing. For example, unfilled conduit seals, unused holes, etc. The enclosure remains properly sealed. Seals should stop water and dust entering the cabinet or enclosure. Normally, seals allow a little pressurized air to escape. However, if the inlet compressed air pressure was too high, the pressure bows out the enclosure's door and sides. This breaks the seals so pressurized air leaks. Question 21. Do barriers and isolators alone make my system safe? Answer. No. The apparatus to be used in the hazardous zone must either be an intrinsically safe apparatus or a simple apparatus. Question 22. What is a simple apparatus? Answer. Any device which does not generate or store more than 1.5 V, 100 meters A, and 25 meters W, including inductance and capacitance. Question 23. What are the factors driving the increased demand for purge and pressurization systems? Answer. The increased demand for purge and pressurization systems is driven by a number of factors. Following are some of the key factors: the continuing focus on safety in hazardous working locations, the high cost of designing, certifying, and installing electrical equipment as either explosion-proof and/or intrinsically safe, the increased use of automation requiring electrical/electronic controls in hazardous work environments. For example, robotics, programmable controllers, computers, printers, calibrators, analyzers, and video displays. The recent boom in the petrochemical industry brought on by the lower cost of petroleum-based raw material. Question 24. What is MIC? Answer. MIC is the minimum igniting current. This is the ratio of the minimum current required from an inductive spark discharge to ignite the most easily ignitable mixture of a gas or vapor, divided by the minimum current required from an inductive spark discharge to ignite methane under the same test conditions. In the class/division/group system of hazardous area classifications, MIC ratios are used for groups B, C, and D to define the types of hazardous gases in the surrounding atmosphere. Question 25. What is MESG? Answer. MESG is the maximum experimental safe gap. This is the maximum clearance between two parallel metal surfaces that has been found under special test conditions to prevent an explosion in a test chamber from being propagated to a secondary chamber containing the same gas or vapor at the same concentration. In the class/division/group system of hazardous area classifications, MESG distance values in are used for groups B, C, and and D. to define the types of hazardous gases in the surrounding atmosphere. Question 26. What is SCFH? Answer: SCFH is the standard cubic feet per hour is the volume flow rate of a vapor at standard conditions of pressure and temperature and humidity 14.7 psia 68 Fahrenheit and 0% relative humidity. Question 27. What is SCFM? Answer: SCFM is the standard cubic feet per minute. It is the volumetric flow rate of a gas corrected to standardized conditions of temperature and pressure. It is related to the mass flow rate of the gas by a multiplicative constant which depends only on the molecular weight of the gas. Question 28. Is there a specific NEMA, National Electrical Manufacturers Association, enclosure specified by NFPA 496 for use with a purge/pressurization system used in a hazardous environment? Answer: NFPA 496 does not specify a particular NEM rating for an electrical enclosure that uses a purge/pressurization system in a hazardous environment. Most manufacturers of purge/pressurization systems recommend electrical enclosures that minimally meet the rating of NEMA 4 or NEMA 12 enclosures respectively. If the enclosure has windows, it's important that the windows be shatterproof. It's best to make sure there is no tape over cutouts and/or openings in the enclosure. Question 29. What are the advantages of purge and pressurization systems as a method of protecting electrical equipment in hazardous locations? Answer: following are advantages of purge and pressurization systems. Overall safety, most cost-effective, low cost of protection/volume of enclosure, low maintenance, not limited by quantity, volume, shape, power requirements, or physical location of electrical equipment, capable of reducing moisture, heat, dust, and corrosion within protected equipment, can improve performance of equipment within protected enclosure, allows for quick and easy access to protected equipment, adds to the life expectancy of instrumentation within electrical enclosure,